As I told you in the beginning itself, if we want to know the exact electrical behavior of the capacitor, and the idea behind the development of the capacitor as a device, followed by the way in which the capacitance of a capacitor is dependent on the dimensions and the media. Listen carefully. The resistance of a resistor, capacitance of a capacitor, and the inductance of an inductor depends on the medium used in the device and its dimensions. Pakka. If we want to know the way in which it depends upon the medium and the dimensions, we will be able to design a capacitor of required capacitance. Designing a capacitor refers to fixing the medium inside and the dimensions of it. Once again, this is the subject ultimately that helps you in understanding the electrical behavior of a capacitor, the development of it, and the way in which the unit of a capacitor, capacitance, depends upon the dimensions and the medium. And now giving you the systematic development. Listen carefully. Capacity, when it comes to, we normally talk about a vessel or a tank, water tank. Capacity talks about what? The ability to store a particular thing, like water. If it can store more water, its capacity is more. That's what we said. 1,000 liters, 2,000 liters, 3,000 liters, we call. Ability to store is capacity. Now, ability to store charge per unit potential, that is the standard, is capacity of a conductor. Listen carefully. Consider an arbitrary shaped conductor. Arbitrarily shaped conductor. Charge it with Q coulombs. Please keep answering. Charge it with q coulombs. Where will the charge reside? On the surface, correct? Whenever there is a charged object, it creates electric field in the region surrounding it till infinity. We know that. Only at infinity the field of any charge becomes equal to 0. Now, from infinity, if I move unit positive charge onto some point on this object and see the amount of work done, it gives what? The potential, let us say, from infinity, I move unit positive charge to this particular point. Total work done will be given as what? The potential V. Any doubt in this? Because it creates the field. Because it creates the field, there is potential at each and every point. Now what I do is, I will bring that unit positive charge from infinity to a point on the surface of this object. There is a potential V. Please understand now. Since the charge resides on the surface of this object and the field lines are everywhere perpendicular to its surface, irrespective of whether that surface is regular or irregular, at each and every point, the field lines, flux lines, and hence the field lines are perpendicular to the surface. Because the field lines are everywhere perpendicular to the surface, at each and every point on this surface, the potential will be? Will the potential be different at different points on this surface? No. It is same at each and every point on the surface. Next. See the beauty of it. Anyway, the potential at any point is the total amount of work done in bringing a unit positive charge from infinity to the given point. If V is the work done in bringing a unit positive charge from infinity to any point on the surface, because surface is sure to be the equipotential surface. Why it is equipotential surface? Because I told you that every charged object creates the flux and the flux is perpendicular to the surface at each and every point on it. Because the flux and the field is perpendicular to the surface at each and every point, the surface becomes equipotential surface. Now, what will be the potential at any point inside? What will be the potential at any point inside this object? Also, why? If there is no opposition, we did not do any work, right? Till the surface, the field was there. Will there be any field inside? Will there be any field inside? No. Because it is there on the surface, the flux lines only go out. There is no field at any point inside this solid object only. Practically, it is a solid object. Because there is no field, but the field is there up till the surface, beyond which, if I go into, there is no field, because of which there is no opposition. If there is no opposition, I will not do any work. So, listen carefully. If we consider a charged object, the charge resides on the surface. On its surface, on its. Due to this surface charge, at each and at every point on the surface, at every point on the surface, E bar is perpendicular to the surface, beyond which it can take any shape. I'm not worried about it. E bar is perpendicular to the surface. Making the surface an equipotential one. You agree this? If V is the potential at any point on the surface, any one point, at any point on the surface, every point on and inside will be there at the same potential. You agree this? So we say that the charged object is at a potential V. Basically, charged object. A statement will be taken, will be proved through example. If the total charge when the total charge on the conductor is Q, if its potential is V, its potential when the charge is K times Q will be K times V. You agree this? We saw the potential at a point because of a point charge only, directly proportional to the charge. Potential of a charged object. Now I told you why we are calling that object to be there at a potential V. Because every point on and inside of it will always be there at the same potential. If you double the charge of the conductor, the potential gets doubled, and say that Q is proportional to V or V is proportional to Q. Okay, this is what is it taken. If you say that potential got doubled, definitely the charge on it should have been doubled. The charge present on the object is directly proportional to V, and Q is equal to CV, where C is the constant of proportionality called as hey, what is this called as? Capacity of a conductor. Capacity, it's not capacitance. No. If you are there in my previous class, you can tell it. Constant of proportionality called as capacity to hold. Capacity of the conductor to hold charge. Capacity. What capacity? Of the conductor to hold charge. Check it. If it is a conductor, its capacity is Q by V. You give some charge Q to the conductor, determine its potential V. Take the ratio Q to V. So that is the capacity of that conductor. Example, where we can determine now. For everything we can determine, but they are all very difficult, and we'll talk about only thing which can derive. One case if we say, the other cases are normal. Accept. Listen. Truth it is. Consider a hollow or solid. I'm not worried about it. Spherical conductor of radius A. Kept in the medium with permittivity epsilon. And charged with Q coulombs of the charge. Plus I am assuming, but you know that it is true for Q to be negative also ultimately. Q coulombs of charge. It definitely comes onto the surface, no doubt. Even if it is a solid sphere, charge ultimately will not stay inside. Normally when it is charged, it will come onto the surface. Now, you know that this creates field with spherical symmetry, where the flux density at any point on the sphere of concentric sphere of radius r is q by 4 pi r squared, and the electric field intensity at any point on the sphere of radius r is what? Q by 4 pi epsilon r squared ar. Listen carefully. For all r greater than or equal to a, 0 for r less than a. You are comfortable with this because we did it, we discussed it. Now, what is the potential? Potential at any point. Definitely, I will take the most comfortable path because it is the particle field. Infinity to straight away to that point. I'll say in spherical coordinate system, it is radial. What is the potential at this point? V is equal to minus integral infinity to a. Because I want to know the potential at any point on it. Minus integral infinity to a q by 4 pi epsilon r squared ar is E bar dot dr ar in the spherical coordinate system only. Ar dot ar is equal to 1. Q by 4 pi epsilon r squared. Dr is what? Q by 4 pi epsilon 1 by r from infinity to a. Correct. Q by 4 pi epsilon minus 1 by r squared integral is 1 by r from infinity to a, because of which it is q by 4 pi epsilon a minus 1 by infinity is 0, because of which this is the potential so many volts V. And I am sure that at every point on the spherical surface, potential is q by 4 pi epsilon a. From there, if I go inside and to any point inside, because there is no opposing field, there will be no potential difference between any 2 points inside. Because of which to come here to any point inside, I should come till the surface, moving it against the field. Once I reach the surface and go inside I need not do any work. But potential at any point is what? The total work done in bringing it from infinity to the given point. This is, I think, you agree with me, that is the potential at any point on and inside this metallic sphere. We say that V is the potential of that sphere itself, because every point on and inside is at the same potential. This object, this spherical charge, is said to be there at the potential V given by q by 4 pi epsilon a. Q is not a point charge, it is distributed on the surface. Now, we can write q is proportional to V, right? There is a constant only relating V and epsilon. What are those constant? A, the radius, the dimension, epsilon, and the constant anyway. So the capacity of this spherical conductor of radius A, kept in a medium with permittivity epsilon, C is equal to what? Q by V is equal to 4 pi epsilon A is the capacity. So many farads only. Coulomb per volt. 1 coulomb per volt is 1 farad.